We are at IIT Hyderabad lab, and this particular machine is Raman Spectrometer, and today is 27th of February, and on on this date only, 27th February, Raman has announced his discovery of Raman scattering to a press conference, which was published on next day newspapers, and that is how the National Science Day is celebrated. Now, the Raman scattering is basically when any light falls on some material, then it scatters. That is why our sky is blue, and at the sunrise, sun is reddish and all that. So, this is a very natural phenomena of scattering. And most of the things that we see with our eyes is also through these scattered light. But in this normal scattering, the wavelength of light which is incident and wavelength of light which is scattered remains the same. So that's the kind of normal scattering. Now, in the Raman's experiment, what she discovered that in certain kind of liquids, if this light is incident and you study the scattered light, then the scattered light has a different wavelengths, and so it was a kind of a different scattering, totally different, not known at that time that this kind of scattering is also there. So hundreds of liquid samples with different chemical compositions he tried, and it was confirmed that this special kind of scattering in which the wavelength changes is there. And very interestingly, the wavelength not only changes on the upper side, it also changes on the lower side. Upper side is still understandable, because if some light is going with a shorter wavelength, the energy is more, and then you that material absorbs it and scatters it. So a lesser energy emission is natural, but emitted scattered light having a larger energy as compared to the incident is something very different. So that kind of things is there. Now, in this particular machine that you see here, the lasers are nowadays is done with laser. Raman did not do with lasers. That time lasers were not there. So from here you have power supplies, and the laser torches are there. You can put many torches of different wavelengths. So that laser light that comes through this, so whatever is inside this chamber, and here you put your material, liquid or solid or whatever you want to study, that you put here, and that laser light falls on it, gets scattered, and that scattered light is again captured here, and then it is taken inside where you have a grating. The purpose of grating is, if the grating receives light of different wavelengths, then it will deflect it in at different angles. So you exactly know it. There's no mixing after this grating. So you exactly know what kind of wavelengths you are receiving in the scattered light, and then this all information, which is detectors are there. No electrical signals come in this this computer, and then it makes on all kinds of analysis and shows us this kind of spectrum. And what is this spectrum that you are seeing? It is the only the wavelength at which lot of scattered light is coming. The incoming radiation, for in this particular example, this incoming laser has been selected at 532 nanometers, but you can see this is 500 written here, 550 written here, this middle point is 525, and the peak is slightly left of it, is slightly less than 525, and here you can read actually this is 522. So the scattered light has a wavelength of 522 nanometers, whereas the incident light was 532 nanometers. So this is called Raman shift. Okay, and this is plotted 1 by wavelength, the difference of 1 by wavelength. So that is how it is done, and through this kind of information, that shift depends on the chemical structure of the sample. All right. So through this shift, you are peeping inside that chemical, and you know all kinds of molecular structure information hidden there, which can be revealed by this kind of a spectrum. So it's a very, very favorite techniques for all kinds of chemists and now biologists and industrialists, so that they know what kind of molecular structure is there in their objects and what kind of effects it will be giving. So that's about this. Happy Science Day.